Assalamu alaikum. Last time we talked about classes, constructors, and destructors. Yalla. Oh, the attendance. Alaikum assalam. So when we talk about classes, we talk about class definition, objects, which are variables of type class. And then we also studied member functions, how to invoke them, how to call member function of a class. And we also studied constructors and destructors. So I hope you review this well for the quiz and for the midterm, of course. Today we talk about two topics, assignment of class object and passing class object to functions. Now, what is the assignment operation? We know what is the assignment. What is the assignment operation? The assignment operation is one equal sign. Assignment operation is one equal sign. And we hope that we are able to assign class. For example, last time we had seen the class rectangle example that has two double private data fields, double and double. I think maybe length and width. And we have also seen public member functions. Public member functions. Some member functions. And we hope that we are able, after declaring rectangle R1, R2, to assign objects of type rectangle. What are the operations allowed on objects of type class? Is there any operation? Are we allowed to have, for example, this is like, for example, inside the main. Are we allowed to have R1 plus R2? Is this defined? Are we allowed to have C out R1? Is the stream inserter operator defined for objects of type class? Is the plus operator defined for objects of type class? So the answer to all of this is no. All those operations are not defined, and the only operator that is defined is the assignment operator. We can assign entire structure, entire objects of type class. Okay? So this is similar to assigning structures. This is similar to assigning structures. So how does it work? If we declare two objects R1 and R2, and then we assign R2 into R1, then it simply copies the corresponding data fields. So of course the member functions are not copied. This makes sense. What does it mean to copy a function? It doesn't mean anything. But the data is copied in the corresponding field. It means that they must have exactly be of the same type. So if this is length and width, this is length and width. The length of the second object is copied into the length of the first object, and the length and the width of the second object is copied in the width of the first object. So this is allowed, but it is the only operation that is allowed on full structure. Other operators are not defined, but you are allowed to redefine those operators for the classes. We are going to see after the midterm how to overload the operators, how to redefine the plus operator, how to redefine the inserter operator so that it has a meaning for objects of this type of class. So this is exactly what I said when using the assignment operator with objects of type class. The values of the member attributes of the right operand get copied to the member attributes of the left operand. Well, what does it mean? It means the corresponding ones. If you have a length and a width, the length is copied to the length and the width in the width, not vice versa, not the opposite. Which is exactly what we have seen with the struct. So it was a good introduction for classes. But there is a warning here, but we're not going to study it. It is out of the scope of this course. That we have seen last time class which data members were not float or double, they were pointers. So if we have pointer data members, which means that the objects do not contain directly the data, but the object has a pointer that points to the data. So the data is here, for example, and the data is stored here. Okay, so if we have pointers like this, you are still allowed to do assignment, but you should be very careful because most probably the assignment will not do what you are expected to do. And it might result in a dangling pointer. So we need to study what are dangling pointers, and the solution to this is copy constructor. So maybe this needs 2 additional lectures, which will be out of the scope of this course. The only thing that we need to understand now is that when you assign objects whose data members are pointers to dynamically allocated data, you should be very careful when using the assignment operator. بس هو ده كده ملخص الكلام. طيب. So let's look at an example immediately. Let's move on. This is our example without pointers, because last time, the end of the lecture, when we started destructors, we had seen an example with the pointers, remember? Or maybe you don't remember. Well, you will remember one day. So here we have the data directly stored in the class objects, not through pointers that dynamically allocate space. We have 2 private data members. Here they are. We have 2 constructors that overload each other. One default constructor, we call it the default constructor, and one parameterized constructor. Okay. We have one destructor. How do I know all of this? It is a function. A function is recognizable by the parentheses that has the same name of the class and no return type, so it is a constructor. And we have the 4 setters and getters, 2 for each data field, a setter and getter for the length field, a setter and getter for the width field. And we have the utility function getArea that returns some function of the length and the width. The constructor, as we have seen last time, the default constructors assigns the initial values 1 and 1 to the length and width fields of the rectangle object, and the parameterized constructor uses the values of the past arguments as the length and width fields. Here the destructor is not doing anything, so it is a useless destructor. There is nothing, there is no garbage collection that needs to be done when we exit objects of this type of class, because the data is automatically cleared by the compiler. So here the destructor will not do anything, and if we do not define a destructor, it will be the same thing, because the compiler will define for us a destructor that doesn't do anything, exactly like this one. The member functions, just as a reminder, the set length and set width assign the private length and width data fields to the argument values that are passed to them, and the get length and get width return the private data members, and get area just multiplies both of them and return the product. خلاص؟ طيب. So this is the rectangle class example. We have remembered it. What is new today? We're going to make sure we understand how the assignment operator works with classes. So how can you trace this code? How can we trace this code? This code starts definitely at the declaration statement. The declaration statement is not useless statement like we have been considering it before studying classes. Now this declaration is going to call to invoke yesterday the constructors. Why? Because R1 and R2 are objects of type class. So here rectangle R1 reserves space in memory and calls that space R1, and that space is large enough to fit the data that is contained in an object of type rectangle. What is the data that is in an object of type rectangle? It is a set of two doubles. So we have a double length and a double width. And similarly, it is going to reserve space in memory, call that space R2, large enough for two doubles, length and width of R2. But in addition to this, it is going to search for a constructor. Why? Because R1 is an object of type class. So do we have a default constructor? Do we have a parameterized constructor? When do we have a default constructor? We have a default constructor if no constructors at all are defined. If we don't have any constructors at all in the definition, if we don't have this definition, we don't have that definition, then we have a default constructor that does nothing. Or the other situation, if we have an explicit definition for a default constructor. So here we have an explicit definition for the default constructor, which assigns the values 1 and 1 to the length and width. So it is simply assigning the values 1 and 1 through the constructor. We are still in the first statement, the declaration statement. How about the R2 declaration? The R2 declaration also is going to look for a parameterized. Do we have a parameterized constructor or no parameterized constructor? Yes, we do have a parameterized constructor that takes exactly the values of the arguments and assigns them to the length and width fields. So here it is going to take the 2 and 3 and assign them to the length and width of W2 of R2. Having done that, we are finished with the first statement, the declaration statement. So this is how I would like to see you tracing code that has classes. And then we have cout R1 equals. So this is going to print R1 equals. And some space. And then R1.getL. What does R1.getL do? R1.getL is a function call. But not any normal function call. It is a call for a member function. How do I know it is a member function? Because we have this dot operator. So it is a member of objects of the same type as R1. What is the type of R1? It is a rectangle. So the first thing we're going to look, since we have this dot operator, then I'm going to look inside the definition of rectangle. Do I have a member function called getL? Yes, we do have a member function called getL. So this is the first thing. Is it defined? Because if it is not defined, then this function header doesn't do anything. Yes, it is defined here. The function that is here returns the value of length. But what is length? What is the value of length? Length doesn't have any value. So we must know the length of which object. Where is that object? The object that calls this function. So here, it is the object R1 that is calling the function getL. So getL is not just getL like this, without any parameters and without any object. If you just type getL like this is an error. It doesn't know which object it should act upon. But here, because it is a member function, the only way to call it is by using the dot operator, the membership operator. We realize it is a member of the class rectangle. Then we are going to call getL using a pointer that points to R1. So now when we call getL, we are inside this function. Inside this function, I have no idea what is length. What is the value of it? We know that length is a field, is a data member, is a member variable of the class rectangle, but we don't know its value. The value is the value inside the length field of R1. Why R1? Because it is R1 that is calling the length. So this is how you should be tracing. And what is R1? What is the length inside R1? It is 1. So this is why it is going to print this 1 on the screen, followed by this comma, and then R1.getWidth. Exactly the same procedure. This is going to invoke a member function called getWidth. Here is the member function, getWidth. It is a member of rectangle. How do I know it is a member of rectangle? Because of the scope resolution operator that connected to the rectangle class. It returns the width, but we have no idea width of which object. So I must get back to the object that calls me, which is R1. So in that case, I print the width of R1, which is 1. It's only at that time that we know how which object we should be dealing with. So when we call a member function, we don't have any parameters here. We don't have any parameters here. So we don't know which object should act upon. It is automatically passed a pointer to the object that calls it. In that case here, R1. Or in the next statement, R2. So getL is called again. The body of getL is just return length. So it is exactly the same statement, but it returns another value because it is the length field of R2. So in that case, it prints R2 equals. This is why it prints R2 equals. And then the length of R2, which is 2. And similarly for the 3, that comes from getW3. GetW of R2 passes a pointer to R2 inside the function getW, and inside getW we know that we are pointing to R2. أيوة اتفضل. عليكم السلام عليكم. أيوة اتفضل. So we know that we are pointing to R2, the same R2 in the main. Inside the function we don't know. So you must have something that points back to the main, which is this hidden pointer, this pointer, that is pointing back to R2, which value is 2 and 3 as we have set before. So we know that width here is the value 3. خلاص واضح how we solve such problems. Then we have that statement, R1 is assigned the value of R2. And we said that this assignment operation copies the field values from one class to the corresponding fields in the other class object. So basically 2 is copied into 1 and 3 is copied into 1, and this makes the new values 2 and 3. So now when we print using the cout and the getL and getW member functions, it is going to print 2 and 3. واضح؟ طيب. Now we have talked about assignment. What is the purpose of talking about assignment? الهدف من الكلام عن assignment. The purpose of talking about assignments is as an introduction to function calling. When we have a function call, let's add an additional page at the end. Okay. A function call involves assignments. بمعنى, if assignments were not defined, then you cannot call a function. Why? Let's look at a simple function. For example, int function int a, and this function return for example a plus 5. واضح? And then we have the main function somewhere else, int main, for example we have an int x here in the main function, int x, and x equals function of 3, for example, and then cout x. A very simple code. What does this code print? What does this code print? Hmm? 8. Very good. This code is going to print 8. How did this function call happen? This is the what we'd like to talk about. We always say that the arguments are copied from the function call to the parameter of the function definition. What does copy mean? It means we have an assignment. So we do have an assignment. A equals 3. Because assignments are defined, we are able to pass arguments to the functions. Where else do we have an assignment? The function. We also have an assignment here, the return. So here a equals 3, then 3 plus 5 is computed inside the function, equals 8. Then this 8 is returned. How is it returned? Here. So we have another assignment, x equals 8. And so this code is going to print the value 8. طيب. So we have two assignments here. Assignment when you pass the data to the function, and another assignment when you return the data from the function. And the reason we talk about this, what if this function did not have a simple data type, but the data type was of type class, for example, the rectangle that we have been using so far? What if the return type was also a type class, for example, the rectangle that we have been using so far? So in that case, we must have assignment of classes defined, assignment of objects of type classes defined, so that we are able to pass a class object to a function and return a class object from a function. And fortunately, assignment is defined, so we can use it. as such. We can use it this way because assignments are defined. So here we define a function, non-member function, print rectangle. A print rectangle simply prints the values of the length and width. But this function is not a member function. This function is going to take a parameter of type object, of type rectangle class. Its parameter is an object of type rectangle. Now, how do we execute this program? It is not executed like the previous one. Let's start here. So this is the declaration of the object R1. It is going to reserve some space in memory in the segment for the main function, R1. And it is going to store the values 2 and 3 because we know that we already have a parameterized constructor. It is defined here, and it takes the values of the arguments and places them in the local, in the data fields, length and width. So it is done like that. Then we have a call to the print rectangle function. The call to the print rectangle function passes the control here. Control is passed here. And the R1 argument is copied inside R. So here, because we have defined the assignment operation, R equals R1, then the 2 and 3 are copied, a separate copy, inside the data segment of the function. So inside the stack of the function, R will have 2 and 3. Another R, a copy of this R1 exists, lives inside the function. So this R has the same data fields, 2 and 3. The same values as the data fields in the main function, R1. And then it is going to print the length equals r.getL and width equals r.getW, which reads the private fields of R, which are the 2 and the 3, and prints them this way. Length equals 2, width equals 3. طيب. This is how the program works. But how will the program not work? Because I believe that we learn by making mistakes. So if we don't make mistakes, if I give you the correct answer the first time, there is no chance to learn new things. Now, why do we call this function in this way? Print rectangle R1. Why not like we have been doing all the time? R1 dot print rectangle. So the first one, first, are they both correct? Or one is correct? Well, you don't know.
Are they the same? Kind of.
We don't have a function print rectangle. Oh, we do have, it is here. But it is not a member of R1. So we do have, so here we must be careful when dealing with functions. This function, print rectangle, is not a member of the class. How do you know it is not a member of the class? How do I know print rectangle is not a member of the class, but set L, set W, get L, get W are all members. The scope resolution operator, exactly. Because we have a scope resolution operator, we can know which functions are members of the class and which are not. So the first thing that we know is that print rectangle is not a member of the class rectangle. So what are the implications? تبعات هذا الأمر. What are the implications of not being a member function? First thing, we cannot call it using a dot operator because it is not a member of R1. This is wrong. The second thing is that since it is not a member, then when you call it print rectangle, you cannot call it like this. Print rectangle and then empty braces. Because if you put the empty braces, then how inside the function we are going to know which object I should act upon. أي الأوبجكت يجب أن يعني يعمل عليها الفانكشن تنفيذ الفانكشن should act upon a specified object. طيب again, in those member functions we didn't have arguments, we didn't have parameters, but still the function knew which object it should act upon. How? Through the dot operator, through the object that called the function. But here, since print rectangle is not a member function and there is no dot calling, then we don't know which object it is acting upon unless and until you pass it as a parameter to the function. So it must be passed the usual way, the old way that we learn in 101. How to use functions. So it is passed as an argument to the function. Okay. Second thing, here in the member functions we used to write return length بس, and it understands what it should be doing. Return width بس. Why didn't I do the same thing here? Why didn't I write C out width, C out length? Why is it wrong just to put length and width here? Why is it wrong? And it is not wrong to do it with the member functions. Member function are allowed print width and length directly. Because width and length are not defined inside this function. So you cannot use a variable that is not defined in the function. You can say the same thing. Length and width are not defined even in the member functions. How can you still return them? They are not defined. They are not defined in the function, but they are defined in the class in which this member function is defined. So by the scope resolution operator, we know that get L and get W are members of the class rectangle. And by looking back at the definition of the class, together in the same scope, in the same class, the member function and the data are defined together. So get L, get W, get area, all the member functions can directly access the length and width. On the other hand, non-member functions like print rectangle cannot access length and width. So it is wrong just to write length and width because length and width are not defined type. But here we have R, and R is of type rectangle. Can I, instead of width, write R dot width and R dot length? Okay, so now we know that width is not defined because it is defined in the class type. So I will write R dot width, C out R dot width, or C out R dot length. Okay, length is not defined in the function, but it is defined inside the class, and R is an object of the same type of class. Can I do this, R dot width and R dot length? The answer is no. Why not? So wrong for the second time, because width and length are private data. If they were public data members, we would be able to do this, but they are private data members. So we cannot call directly width, we cannot use directly width. Width is not defined at all, it is not defined in this scope. R.width is defined, and the compiler knows very well that width exists inside R, but it knows something else, that width is private, so you cannot use it this way. So this is how to call the function, and this is how not to call the function. And we have similarly a function call to print area. Print area simply moves the control to a print area function. It passes a copy of R1 inside the parameter R. Again, inside the function, we cannot directly use the length and width because they are private. So we must use a public member function to access the private fields of the parameter, which is the get area in that case. And the get area simply returns the area, and the print area function is going to print or see out that value. area equals 6. خلاص واضح الكلام. شكرا.